Welcome to this video on solving math problems. In this video, we will look at effective problem-solving strategies in math. What do you need to know? The difference between successful and unsuccessful problem solvers lies in their beliefs about problem solving, themselves as problem solvers, and about ways to approach solving problems. In other words, it's all about you. When students believe that math problems can be solved quickly and easily, they sometimes don't immediately know how to solve a problem, and then they give up. Stop. When you get stuck, please go. Keep trying. Always keep trying. Try a new strategy. Ask for help. Just do something. Doing something is always better than doing nothing. There are many different steps to effective problem solving in math. Here are the Super 7. First step in the Super 7 is to read the problem, and then read it again. The second step is to underline the question. Make sure that you understand what is being asked. The third step is to circle important numbers. Remember, not all numbers are important, so don't get tricked. Number 4 is to choose a strategy, and then try another one if that one doesn't work. You may have to try several strategies before you find one that actually works for you. The fifth step in the Super 7 is to solve the problem. Next, you have to check your answer. Sometimes your answers can be completely out to lunch, and you'll never know unless you check. And then finally, the seventh part of the Super 7 is to explain your work. We will explain how all of these steps work in the following slides. Step number 1, read the problem and then read it again. Understanding the problem in the first place is super important so that you get a sense of what is actually being asked in the problem in the first place. Read the problem carefully and restate it in your own words if you have to. Step 2. Underline the question. Miss Smith baked some cookies for the bake sale. There are 16 cookies in a batch. She ate 1/4 of the first batch. She then baked 2 more batches of cookies. How many cookies does she have left for the bake sale? Here we have to underline the question. And the question usually is the last sentence of the problem. Be careful though. There may be more than one question being asked and have different steps involved in solving the problem. Some problems can be very complicated. In this case, though, how many cookies does Miss Smith have left over for the bake sale is the question that is being asked in this problem. Step 3. Circle the important numbers. We're back with our problem of Miss Smith and the bake sale cookies. If we look at the problem, we see that one important piece of information is that there are 16 cookies in a batch of cookies. The second part that is really important is that she actually ate 1/4 of them. She must have gotten hungry while baking. And the last piece of information is that she baked 2 more batches of cookies. The next step in the Super 7 is step 4. Choose a strategy, and if that one doesn't work, try another one. Keep going until you find a strategy that actually works for you. Some strategies are better suited to other problems, and we'll be discussing them shortly. Figuring out what kind of strategy to use can be challenging. You need to be able to translate words, English words, into math language. Like in any language translation, you need to look for keywords to help you figure out what to do next. We need to look at math lingo, at math language. When we're looking at addition problems, there are some key phrases and words that are clues that addition is the operation that you will be using in the problem. Things such as, what is the total? How many altogether? How many in all? The sum is, and here you need to understand that sum is the answer to an addition problem. 2 plus 2 equals 4. 4 is the sum. What is the perimeter? Perimeter is actually just an addition problem. What is the sum? Increased by, more than, combined, together, added to, and more. So addition is used when any of these phrases or words are being used in a word problem. Let's move on to subtraction. Like addition, there are certain words and phrases that are giveaways that subtraction is the operation that is being used. Things such as, how many fewer? How much change is left? How many are left? Decreased by? The difference between? The difference of? What is the difference? And here, difference is the answer to a subtraction problem. 9 subtract 6 equals 3. 3 is the difference between 6 and 9. Fewer than, minus, less. How much is left? Those are all of the subtraction phrases that are clues that subtraction is the operation being used in a word problem. Multiplication. Groups of, in a batch, in a group, multiples of, a product of, and here product is the answer to a multiplication problem. 2 multiplied by 3 equals 6. 6 is the product of 2 and 3. What is the area? Area is always a multiplication problem. You have to multiply length times width in order to get the area of a shape. Increased by a factor of, multiplied by, times, of. These are all the multiplication clues, phrases, and words that give away the operation being multiplication in a problem. Now, finally, let's look at division. Just as in the other three operations, there are several key phrases and words that are giveaways that division is the operation you need to use in a word problem. Things such as divide into groups, percent, and percent is where you divide by 100. Divide into blank groups, per, out of. What is the quotient? And here, quotient is the answer to a division problem. 9 divided by 3 equals 3. In this case, the last 3 equals 3 is the quotient of the division problem 9 divided by 3. What are the factors? How many per? The quotient is a, and in this case, it would be I earned $9 an hour. Or I read for 34 minutes a day. So that's per day, a day. The ratio of. Fractions also sometimes mean division. Please be careful of this. We'll cover this more on another lesson when we talk about fractions, but just remember that in the back of your head when you are learning about solving math problems. Each, and those are all of the division clues, key words and phrases that will help you understand that division is the operation being used in a problem. Going back to the Super 7, we're still in step 4, choosing a strategy, or trying a different one. Figure out what operation you will probably need by translating the words into math language. So in this case, with Miss Smith and the cookies, we are looking at 16 cookies in a batch with 3 batches. We could do 3 multiplied by 16, or 16 multiplied by 3. However, Miss Smith got hungry while she was baking and she ate 1/4 of the first batch. So, looking at the question, how many cookies does she have left for the bake sale, we can assume that there is subtraction somewhere in this problem. Here are some possible strategies for you to try. You may need more than just one. Working backwards, drawings and illustrations, making an equation, visualizations, make a table, guess and check, or use your own strategy. If something else is better, go ahead and use your own strategy. Let's look at some of these in more detail. First off, working backwards. A problem that you would probably use the working backward method on would be something along the lines of this. Marianne flew from Halifax to Calgary. It took her 3 hours to get from Halifax to Toronto and 4 hours to get from Toronto to Calgary. If she arrived at 4 p.m. Halifax time, what time was it when she left? So our first step is to underline the question. In this case, what time was it when she left? The next thing we need to do is circle the important numbers. In this case, we have the times. It took her 3 hours to get from Halifax to Toronto and 4 hours to get from Toronto to Calgary. There is one more piece of information that is very important, and that is that she arrived at 4 p.m. Halifax time. Now, the reason I put Halifax time in there is because otherwise we're dealing with time zones and it becomes a much more complicated problem. In this case, she left from Halifax. Her watch was set to Halifax time. When she arrived in Calgary, she didn't change her clock, her watch, and her watch is still reading Halifax time. In fact, just so you know, there is a 3-hour time difference between Halifax and Calgary. And in fact, 4 o'clock Halifax time would be 7 p.m. Calgary time. But we are not going to worry about that for this problem. To solve this problem, I would use a timeline, like what we did when we were looking at the time problems. And I would mark off 3 sections. The first section would be Halifax. That is where she left from. The second section would be Toronto, and the third section would be Calgary. Now we know that she arrived at 4 p.m. in Calgary. And now we have to work backwards. So we know her arrival time was 4 p.m. So the flight from Calgary to Toronto, Toronto to Calgary, took her 4 hours. So we have to subtract 4 hours from 4 p.m. and that gives us 12 p.m. We also know that the flight from Halifax to Toronto took her 3 hours. So we have to take 3 hours away from 12 p.m. And that leaves us with a departure time of 9 o'clock a.m. So In answer to our problem, Marianne left Halifax at 9 a.m. to fly to Calgary. This is an example of how working backwards from the end point can help us solve the problem. Another strategy, the second strategy, is using drawings and illustrations. Drawing a picture is a great way to solve word problems. You get the answer and it is easy to see why you got the answer. A good example of a problem that you might want to make a drawing for would be a problem like this. For Stacy's birthday, she got a bag of marbles from her friend Amy. The bag had 6 red marbles, 10 blue marbles, 4 yellow marbles, and 1 green marble. How many marbles does she have in her bag? First thing we need to do is underline the problem, underline the question. How many marbles does she have in her bag? The second step is to circle the important numbers. And here the important numbers are 6 red, 10 blue, 4 yellow, and 1 green marble. So our next step would be to draw out each of those sets of marbles. So if we started off with drawing out 6 red marbles, then we could continue drawing out the 10 blue marbles, then 4 yellow marbles, and finally 1 green marble. So to answer how many marbles she does have in her bag, we can simply count all of the marbles that we have drawn out on our paper, and we end up with 21 marbles in total. So to answer how many marbles does she have in her bag, our answer in a complete sentence would be Stacy has 21 marbles in her bag. Hopefully she doesn't lose any of her marbles. The next strategy we need to look at is making an equation. Making an equation out of a word problem is also a great way to solve story problems. You just take the numbers from the problem and turn them into an equation. All you need to do is read the clues as to what operation is probably being used. Remember, be logical. It needs to make sense. If something is getting bigger, we're clearly not going to be using division or subtraction. So this problem would be a good example of when we would use an equation to help solve a problem. For a school bake sale, 5 students each brought in something to sell. Carrie brought 2 dozen cookies, Sally brought 3 dozen brownies, Max brought 5 dozen muffins, Michelle brought 1 dozen cupcakes, and Sarah brought 4 dozen Rice Krispie bars. How many treats did they have to sell altogether? Our first step to solving a problem is underline the question. How many treats did they have to sell altogether? Our next step is to circle the important numbers. So in this case, we have to circle 2 dozen, 3 dozen, 5 dozen, 1 dozen, and 4 dozen. Now, it is also important to realize that we have to do a conversion here, because the question is asking how many treats did they have to sell altogether, not how many dozen treats. So we need to remember that 1 dozen actually equals 12. So in this case, making an equation goes something like this. 2 times 12, so that's 2 dozen, those are the 2 dozen cookies that Carrie brought, and each dozen is 12. So 2 times 12 equals 24. 3 times 12 equals 36. 5 times 12 equals 60. 1 times 12 equals 12. 4 times 12 equals 48. And what we need to do is add all of those numbers together. And when we do, we end up with 180. So in answer to how many treats did they have to sell altogether, the students have 180 treats to sell at the bake sale. Our next strategy is using visualizations or hands-on. This problem-solving strategy can be the most fun, and it really is very simple. You actually use visuals to do the problem, much like when using drawings, but instead of using pencil and paper, you use the actual things. Here's an example of a problem that would be a good one to use visualizations or hands-on. At the spring fair, children win tickets they can trade in for prizes. A sticker costs 3 tickets, a balloon costs 2 tickets, bubblegum costs 1 ticket, and an inflatable hammer costs 8 tickets. If you have 19 tickets, what are all of the combinations of prizes you could get? Okay, our first task is to underline the problem or the question that is being asked. In this case, what are all of the combinations of prizes you could get? Our next step is to circle important numbers. Here we have 19 tickets, but that's not all that is important in this problem. We need to look at all of the other combination numbers here so that way we can figure out how we can best spend our tickets. So noticing that stickers cost 3, balloons cost 2, bubblegum cost 1, and inflatable hammers cost 8 tickets is very important. So this problem would be easy to solve by actually having things to move around on your desk and make combinations up. The trick here, though, and this is very important, the trick is to keep track of what you've already done to avoid making mistakes. Keeping good records is part of being a good problem solver. So making sure that you don't duplicate a combination is very, very important. However, using hands-on and manipulating actual things is sometimes easier for our brains to work. So keep this strategy in mind in the future. Our next strategy is to make a table or a chart. Making a table is a very organized and simple way to solve some story problems. It is best used when dealing with problems such as Andy decided to start training for a 5-kilometer fun run. If he ran 1 kilometer in the first week and then added 750 meters each week, how many weeks would it take him to reach his goal? So, our first step, again, is to underline the problem being asked. How many weeks would it take him to reach his goal? Next, we need to circle the important numbers. In this case, he ran 1 kilometer the first week and then added 750 meters each week following. We need to reach our goal of 5 kilometers. So here it is really important to understand the conversion that 1 kilometer equals 1,000 meters. Okay, so here we go with the table, and I've already taken the liberty of filling it out. So in week 1, he ran 1,000 meters, which is 1 kilometer. Week 2, he added 750 meters, which gave him a total of 1,750 meters, and so forth. We can see in week 7, after he added the 750 meters, he actually ran for 5,500 meters, or 5.5 kilometers, or 5.5 kilometers. So to solve the problem of how many weeks would it take him to reach his goal, it would take Andy 7 weeks of training to reach his goal of 5 kilometers. So this is also very important to remember that solving a problem means writing a sentence down. We will get to that as we continue on in this video. Our next strategy is guess and check. The guess and check method is usually very slow, but it sometimes can be effective. Guess and check is not the strategy that I would probably use very frequently. However, on a problem such as this, it could be very helpful. 2 sisters' ages add up to 22 years. One sister is 4 years older than the other sister. How old are they? So, first step in problem solving, underline the question. How old are they? Next step is to circle the important numbers. Here the ages add up to 22 and they are 4 years apart. Now this would probably mean that there has to be some addition because two sisters' ages add up to 22 years, and possibly some subtraction as well because the two numbers have to be 4 years apart. So my plan is to select random numbers that add up to 22 until you find two that are 4 apart. So here we go. 10 plus 12 equals 22, but 12 minus 11 equals 2 and not 4, so that's wrong. That can't be right. 8 plus 15 also equals 22, but 15 minus 8 equals 6 and not 4, so that one is wrong too. 9 plus 3 equals 22, and 13 minus 9 equals 4, so their ages are actually 9 and 13. So my answer to how old are they? The sisters are aged 9 and 13, which answers the original question. So the next step in the Super 7 is to solve the problem. Once you have chosen a strategy, now you need to actually solve the problem. We have been solving the example problems as we've been discussing the strategies in the previous slides. Sometimes if you do get stuck, however, changing strategies can help you. Leave your work on the page so that we can see your progress and you can see where and if you make a mistake in the future. When you are solving the problem, you need to remember to show your work. Showing your work is super important. The next step is to check your answer. Checking your answer is a very important step in problem solving. It allows you to see if it makes sense or is completely wrong and out to lunch. Sometimes using the reverse operation can be an easy way to check your answer. For instance, addition and subtraction are opposite operations. So if you have an answer that used addition, if you use subtraction, you should be able to get the original numbers. Likewise with multiplication and division. Multiplication and division are opposite operations. So in order to get the answer for a division problem, if you multiply the numbers, you should be able to get the original numbers in your answer. The other thing you really need to do is to reread the problem. And then once you've reread the problem, look at the answer. Is it reasonable? Is it a sensible answer given what we know and what the question is asking? Finally, the last step in the Super 7 is step 7. Explain your work. Showing your work as you are solving a problem explains your thinking very clearly. It also allows the opportunity to point out where an error was made that may cause an incorrect answer. The final step to problem solving is to state the answer in a sentence. Writing your answer to the story problem is the final step. There are things you need to remember. Number 1. What are you trying to find? Look at the question being asked that you underlined in the problem. Is your answer reasonable? Does it answer the problem that is being asked in the problem? Look for the units the answer needs to be in. Meters, hours, centimeters squared, treats, prizes, etc. Always look for the units that the answer needs to be in and add those units when you are writing your answer. And your answer must always be in a complete sentence. Just writing a number down is not a complete sentence and will only give you part marks when you are being marked on your work. Here is our original problem. Miss Smith baked some cookies for the bake sale. There are 16 cookies in a batch. She ate 1/4 of the first batch. She then baked 2 more batches of cookies. How many cookies does she have left for the bake sale? All right, step number 1. Underline the question being asked. How many cookies does she have left for the bake sale? Step number 2. Circle the important numbers. So, 16 cookies in a batch. She ate 1/4 of the first batch, and she baked 2 more. Okay, it's important to remember that 1 batch equals 16 cookies. In this case, I'm going to draw out all of the pans of cookies that Miss Smith has baked. So here is pan number 1 with 4 rows of 4 cookies, making 16 cookies. Pan number 2 and pan number 3. Here are my 3 batches of 16 cookies. Now, remember that in the first batch, Miss Smith got hungry and she ate 1/4 of the first batch. So that would be 1 row of 4 or 4 cookies based on looking at this picture. Again, if you don't have a clear understanding of fractions and how fractions work in space, now you can draw it out and you can see how 1/4 of 16 equals 4. So that leaves me with 12 cookies left from the first batch, 16 for the second batch, and 16 for the third batch. Now all I need to do is add them up. So 12 plus 16 plus 16 equals 44. So Miss Smith had 44 cookies left for the bake sale. Now, you may be saying to yourself, but there are a lot of other strategies that could be used to solve this problem. Absolutely there are. This is the solution and strategy that I chose to solve this problem. If you have different ways of solving the problem, good for you. Some of you may want to act it out, may want to have 16 cookies and 3 batches of 16 and take 4 of them away. Actually use your hands-on approach. No problem. Some of you can see the equation and be able to do it all in your head. Writing down your work and showing your work is very important. Making sure that you have a clear understanding of the strategies that you're using will help you with solving problems in the future. So here is a reminder of the Super 7. 1. Read the problem and then read it again. 2. Underline the question. What actually is being asked of you? 3. Circle the important numbers. Remember, some important numbers are not important. Choose a strategy, and if that one doesn't work, try another one. 5. Solve the problem. Make sure that you actually solve the problem. 6. Check your answer. Look back. Does it make sense? And then finally, explain your work and answer the question in a complete sentence. And that is the Super 7. You are all done this video. You can now ask your parents for some practice word problems for you to try, or even better, write some of them yourself and come up with some tricky ones on your own. See you in class!